My name is Satya Permala. I'm a geomechanics discipline manager from Baker Hughes. So today we have this session on shallow and deep water exploration as part of the hydrocarbons exploration, production and development theme. Yeah. So in this session, we do have 4 presentations, 4 papers, and all 4 of them are a bit diverse from each other in this deep and shallow water exploration. We do have a deep water installation of TCP systems. We have a hydraulic control lines related paper. We also have deep water exploration potential related strategic discussion, and finally an advanced drill bit technology for to manage the effective rig time and mud losses. Yeah. So it's quite a big of energy mix, but the objective is same, to make it more efficient and effective in the shallow and deep water exploration. So the first discussion is from our colleagues from McDermott, Bhushan Wankde and Colin McKenzie, both of them from McDermott International. The topic is thermoplastic composite pipe, TCP, installation in deep water. So they're going to elaborate on its technology and its value for the deep water exploration. Yeah, stage is yours, Bhushan and team.
Thanks, Satya. Good afternoon, everyone. My name is Bhushan Wankede, and I'm from McDermott International. And I'll be joined by my colleague, Colin. Please, if you can also join with me. We have recently completed the largest deep water development for our clients on the east coast of India. And we're going to talk about thermoplastic composite pipes, how we installed it on that project. So we have installed TCPs on 2 projects. One project was on the east coast of India. That was the first TCP jumpers we installed on offshore India. And the second project, which we did on the Sabah coast of Malaysia, that was also the first TCP jumper to be installed offshore Malaysia. We have included 3 different installation methods for it. That is a VLS deployment, piggyback installation, and the subsea basket deployment. And Colin is going to talk about all these methods in detail. So what is TCP? It's a thermoplastic composite pipe, similar to the unbonded flexible pipes, but it is composite laminate based upon glass or carbon fiber. It's much lighter, and it is DNV certified as well. What are the advantages of the TCPs? Because it's a singular cross section, that means there is no annulus and the outer liner. This gives a standard, this is like similar to a standard unbonded flexible pipe without any problems of any corrosion. Second thing, we can also get all these pipes, something called as a jumper on demand. That means you can reel all these pipes in a one single piece, bring them to a facility where you can cut them and prepare them for as much as possible for your project requirements. And they are suitable to be installed with the conventional lay method, which is basically you can do it with the LCVs or CSVs. However, there are some challenges with respect to the TCPs, that these are lightweight products, so that on-bottom stability of this pipe can be an issue if it is an extremely shallow water environment. Plus, it has a lower maximum tensile capacity, and it has a larger maximum bending radius. Again, we will going to talk about all these points in the subsequent slides, so I'm not going to dwell much on it. So talking about the first project on east coast of India, what we have done is that we have installed 6 numbers, 6-inch water injection jumpers, and then we have also installed 13 numbers, 2-inch gas lift jumpers, piggybacked on a 6-inch unbonded flexible pipe. This is the first project in the world where we have piggybacked a TCP on an unbonded flexible pipe. The length of these jumpers were around 120 meters to 370 meters in a water depth of about 340 meter to 700 meters. So how does this TCP compare with the unbonded flexible? Because we had both 6-inch TCPs and 6-inch unbonded flexibles in the project. So just to give you the idea of the, if you see the weight in the air, it's only 44 kilograms per meter compared to, for a normal flexible pipe, which is quite heavy. Apart from that, if you see the maximum bending radius is quite more than the unbonded flexible pipe, and the tensile strength of this pipe is quite less. So why we opted for a TCP over unbonded flexible in this particular project? Because we had a fast track requirement of getting these jumpers in time for the monetization of the asset. So TCP could meet that requirement. So we brought it in a one single reel and cut to length those jumpers in east coast of India. Plus, this is a relatively new technology. So we have used this little more cleaner technology for use of monetization of these assets. Plus, when we are talking about the timelines, the TCP jumpers were delivered to us within 8 months from the time we placed the purchase order, whereas the unbonded flexible pipes could have taken 20 to 24 months in a normal circumstances. Now we're going to talk about the how we did the installations, and maybe Colin, if you can take from here.
Yes, good afternoon everyone. Colin McKenzie from McDermott. So just a little overview of the different products we had. You'll see on the screen there, on the top is the 6-inch water injection. There's 2 vertical connectors, subsea connectors each side. It has bend restrictors to stop over bending at the entry to the connectors. And just due to the lightweight nature of the product, as mentioned, there was a requirement to install additional ballast to keep the product stable on the seabed. For the 2-inch, as mentioned, it was piggybacked to the 6-inch unbonded. So similar again, but connected, no requirement for ballast, as the ballast is provided by the 6-inch. Okay, and then just another difference with how it was supplied. So the jumper on demand meant that we could take one single reel of product. So for the 6-inch, it was almost 1,300 meters on one reel. We received it in India and Kakinada. There, we prepared it, unreeled it, measured it, cut it to length, terminated it, flooded and hydro-tested those connections, all done in our yard, which is something that's quite different to normal flexibles. So that's the 6-inch. For the 2-inch gas lift, we had almost 3,000 meters of 2-inch gas lift. Similar again, that came on one reel, so for the whole supply we had 2 reels, so that cuts down quite a bit in transportation costs. And then on this occasion we had 13 2-inch jumpers. They were transpooled to these horizontal reels. Again, measured, cut to length, terminated, flooded, hydro-tested, all complete in our yard in India. One of the advantages with the TCP is the end fitting termination is simplified compared to others. So it's a simple slip design with wedges, which doesn't require welding or resin or anything like that. So that facilitates the ability to cut it to length on site and terminate it. Okay, so just going into how we tackled this new product. The vessel that we utilized for this scope was the McDermott lay vessel 108, which is on the screen. So the vessel's a typical flex lay vessel, has a vertical lay system with a maximum top tension 150 tons, with two 75-ton tensioners. It has a large radius aligner to handle the product over the top to avoid overbending, and comes with two deepwater cranes, 100-ton on the stern and a 400-ton midship, as well as two 150 horsepower ROVs. Okay, just looking a little bit more into the lay spread that we used. So on the vessel we have a reel drive system that can handle four 400-ton reels at any time, which we utilize for the 6-inch, and then there's an image of the vertical lay system tower there at the side with the two tensioners, the aligner at the top, and at the bottom there is a workstation, which we'll see in a moment. So in terms of the 6-inch water injection, the reels were loaded into the reel drive system on the stern. First step was we brought the first end off of the reel up over the tower, pulled it down, secured it into the tensioners. Then at the work table below the tensioners we installed all the bend restrictors. Installed the first end vertical connector, and then started paying out. Whilst we were paying out on the 6-inch, we had all the ballast modules being installed from the workstation. And then we got to the second end, same again, over the tower, place the bend restrictors on, hang it off at the table, put the second end connector on, and deployed it and landed it out with the ROV and connected. So that covers the 6-inch. The 2-inch, quite similar. So with the 2-inch we had the 6-inch unbonded, was on the reel drive system, and then you can see there on the port side of the vessel we had a smaller carousel with the 2-inch cartridges loaded into it. So for this installation the unbonded was loaded over the aligner, and the 2-inch was fed through a small chute at the bottom. They both met at the workstation, which you can see here, the 2-inch coming in over a small chute. They were both joined together with piggyback clamps, and so they're clamped together during deployment. Then when we get to the second end, we actually carried out a trial lay just to make sure before we put the connector on. We laid it down on the seabed just to get an idea if there was any rotation or torsion that could have damaged the product, and we then recovered it back to deck, made sure there was no unexpected twist, put the second end connectors on and all the insulation before final deployment and installation. So that covers the Deepwater project on the east coast of India. So a second project we did was for 2-inch jumpers, 150 meter long each. Similar to before with the bend restrictors, the requirement for the ballast due to the lightweight nature. And in this case, we pre-installed them on a basket, lowered the basket with the crane, and utilized the ROVs to pick up the first end, pull it off the basket, connect it in before going to collect the second end and connecting that second end. Okay.
Thanks, Colin. So In summary, what we are talking about in TCP pipes is that it reduces the lead time for based upon the market condition. It reduces the transportation cost based upon the lightweight product. It gives you the flexibility in terms of spare and the future expansion of these jumpers. And it also has a simplified end termination process. However, having said that, we also need to have, though there are a lot of similarities when it comes to the installation of these TCP pipes with respect to the conventional unbonded flexible pipes. However, there are some specific characteristics of this TCP which needs to be taken into consideration, specifically the minimum bending radius, which is the MBR, and the axial tensile capacity. If you take care of these two things, TCP pipe installation is quite manageable. Of course, once the installation team takes these things into account, and as long as you are mitigating all these risks, there are significant benefits of using this in a deep water exploration. Right now, there are no specific lightweight connectors for these TCP pipes which has been used, but there's an opportunity to design and manufacture these specific connectors so that it can be used for the TCP pipes. That's it from us, and I give back 30 seconds to Satya back. Thank you.
Thank you. Thank you, team, for a wonderful presentation on introducing this new technologies in the deep water. So, audience, if you or anyone is involved in this deep water installations, please think, and presenters will still be here, and you can challenge them at the end of the session. Yeah. So let's move into the second presentation. This is from Oceaneering International Services colleagues, Parthi Kapoor and Amit Saini. So the topic is the hydraulic control line filters for subsea high pressure application and overlapping sump design. So it's again another offshore installation innovation which can be listened to very carefully. Yeah. Thank you. Go ahead.
Good afternoon, one and all present here. First of all, I want to express my thanks to India Energy Week for providing us a platform to present one of our...
Ladies and gentlemen, we welcome you to third edition of IEW 2025. The show timings for today are from 10 a.m. to 6 p.m. Please take care of your belongings. Thank you.
Sorry for the inconvenience. So, I want to express my thanks to India Energy Week for providing us a platform to present one of our patented design on hydraulic control line filter for subsea high pressure and high temperature application. Me, Pratik Kapoor, and along with me, my colleague, Mr. Amit Saini, is going to present this design in front of you. Let me give you a glimpse of Oceaneering, first of all. So Oceaneering is a very diverse organization which is involved in various aspects of energies. So we are leader in ROV, and we provide a wide range of products and services. Our organization has a several business, which includes subsea robotics. We are specialized in ROVs, AUVs, and USVs, offshore project groups that take care of offshore services and the renewable energy solutions. Manufacturing products which include subsea umbilical, subsea distribution system, and connection system for the energy products. IMDS, which is related for asset integrity management, and aerospace and defense technologies, which are specialized in defense sector. We have a strong presence in India also. We have 4 offices in India. One is in Mumbai, Kakinada, Pune, and Chandigarh. We are leader in ROV, so we have deployed our ROVs on a rig in India with the deepest dive approximately 3 kilometers for ONGC in June 2013. We have also provided subsea field support for vessels and have supplied our products to refinery plants also. We have best-in-class ROVs, which is operated by 100% by local crews. And our customer consists of upstream and downstream operators, EPC contractors, and our field services. Furthermore, we have delivered a complex solutions to subsea repair pipelines and subsea umbilical for offshore and oil and gas projects. So this design is basically solving a problem for the debris which is going to get ingress in deep water and downhole ICVs and SCSSVs. So ICVs are basically integrated control valve, and SCSSVs are subsurface safety control valves. So this debris tolerance poses a very significant challenge for this control line valves, because these are getting operated in high pressure and high temperature applications. And once any debris get introduced into the system, then it may leads to a downtime of the complete system for 2 to 3 days, which is ultimately going to occur a financial loss for 1 million to 3 million, depending upon the type of the size and the production of the well. There are scenarios in which this debris can enter into the system. First is during the installation of the safety wall itself, and second is during the maintenance of the manifold or the structures, and during the replacement of our connections and coupling. There may be some erosions in the line itself, which can also lead to the debris involvement. So this filter is basically playing a very important role, because the control line is a final line in which this valve is going to get operated, and we need a very pristine fluid for the valve operation. So that's why we are introducing these valves in the control line. This is one of the example where ocean ring control line filters are getting applicated. As you can see in this is used in downhole application in the close vicinity of control line for the subsurface safety control valves. Because fluid is the biggest part in this complete system, so that's why it is very important to get this fluid clean to avoid the downtime of the complete well. Now, ocean ring control line filter. So to address this issue, ocean ring has an effective filtration unit which is ranging from 2 microns to 20 microns to separate the debris from the control lines. These units are specifically designed for working in harsh environment for H2S concentration, and they require absolutely zero maintenance. This filtration unit has an advanced material, for example, Inconel, and has a high reliability performance. To furthermore enhance the capacity and the efficiency of our designs, we have introduced a patented sump feature. So sump feature is basically nothing but it's a kind of sump which is collecting the impurities before the fluid is getting in contact with the filter itself. So basically we are collecting the impurity before the final filtration stage because of sump with the gravity action, and then introducing it to the filter. Now I would like to introduce my colleague, Mr. Amit Saini. He's going to take the further.
Good afternoon, everyone. So I'm going to brief about one of the patented control line filter design, which is overlapping sump control design. As per the well briefed about the sump feature, that this plays a very important role to enhance the efficiency and reliability of our control line filters. Now the challenge and the voice of customer we heard is that these filters are used in deep hole applications where there is a constraint on the size. So we are looking for a solution where a compact design can help, and we are looking to improve the efficiency of our filter. So we innovative a filter which is having a 2.5 times of a higher sump volume compared to the conventional design, and this additional sump volume enhance the capability of filter to handle the debris, and this enhance the operation reliability and key factors to meeting the demanding requirement of such challenging area where there is no maintenance possible for these control line filters. So as the first industry overlap sump design control line filter is complies with the 12th edition of API 14A and the ASME BP Section 8 Division 2 standards. So this control line filter is engineered for high pressure and high temperature environment. So this design is valid up to 15,000 psi pressure and 450-degree Fahrenheit temperature. And it is also designed to serve in adequate environmental condition like S2S environment. So what are the benefit of this sump design filter? So it has enhanced durability in harsh environment. As I told you that this is designed as per S2S concentration and meeting the stringent requirement of NACE and ISO standard. So it has higher sump volume. So it has 2.5 times sump volume, so which helps to improve its life significantly and optimize filtration efficiency. So this filter, we use a cylindrical filter element in place of conventional disc type filter, which helps to increase the filtration area. So larger the filtration area, you can achieve the better flow at lower pressure drop. So the consistent flow is key for the optimal operation of any valve. So simplified installation. So this is a compact design and this can be installed by just 2 clamp seat. So it is much easier and quicker to install. Enhanced reliability. So another feature is enhanced reliability. So it is a compact design and having a less number of welding joints, thread joints, right? So it has a less potential of failure and leakage. So these compact size overall improving the system integrity of the system. So ocean control line filter benefits. So oceaning is able to customize the filters as per the customer requirements. There are scenarios where our standard filters are not fit in the customer requirement, like there are adverse environment condition, different temperature, different S2S concentration, and there are different size requirement or the different flow requirement, and we have customized these filters for our customers. So Oceaning is providing these filters from more than 20 years. So these filters are ready, technically ready for ready and the field proven. And these filters are designed for a life of 25 years. So most of the times these filters get installed in the deep hole and this works 25 years without any maintenance. And there is a there is a high reliability for this filter in place of conventional filters because of some feature. So it has a sump function where all impurities get settled down in advance and which segregates the heavier impurities in first stage, and the only small particles go to the filter element, which reduce the chances of clogging of filters and enhance the reliability. And again, these filters are NACE compliant as per H2S environment. So these are a benefit. Thank you.
Thank you very much.
Thank you.
Yeah, thank you, Oceaneering team, for good examples of this introduction of this new technology in using these hydraulic control lines. Yeah, so with this, from these installations of offshore equipment now, if you have any questions, please meet the others after this session. Now let's move to the next paper, which is from Rystad Energy. The colleague Taib Jain Sharif is the Vice President of Upstream Analysis and Research. The topic is deepwater exploration potential and notable economic advantages. So it is quite a strategic aspect of evolutionary trends that you want to establish here. The floor is yours.
Right. Thank you, Satya sir, for the brief introduction, and congratulations to all the speakers for their insightful presentations. As mentioned, I will be presenting on deep water exploration potential and its notable economic advantages. Now, just to set the stage, let's start off with understanding why exploration in general and deep water exploration in specific is important for India, right? The chart that you see on the top basically shows you the India's liquid production, right? And if you look at the production profile, it is almost on a decline trend. And now when comparing the last 10 years, you see that there has been almost a 23% drop in production, right? And we kind of forecast this production to further drop in the upcoming years as well, right? And this drop in production are also seen in some of the legacy basins such as your Mumbai offshore, your Rajasthan, Cambay, etc., where although there are news now that there are production enhancement projects being initiated, but however, with lack of new oil or new exploration, it's very tough to arrest the decline that's going to come in the upcoming years, right? And where on the other hand, when you look at India's crude oil demand, the demand is on proportionally increasing. And similarly, when you compare the last 10 years, you see that the demand has increased by 36%. And we can estimate that this is going to keep on increasing in the upcoming years as well, right? And just to quantify this, just in the last financial year, about 88 to 87% of the crude oil demand were met through imports, right? And to give an economic point of view, about 23% of the total imports bill were spent on the oil and gas imports. So this kind of poses a significant economic challenge to the country and also exposes the country to more of a dynamic or a volatile global prices, right? So there is a certain urge or need of new oil or new hydrocarbon and new more exploration, right? And as we know, usually the big barrels that are there, they usually come from the offshore regions and the deep water regions. For example, you have the likes of Suriname, you have Guyana, you have Namibia, South Africa, etc. So you have these examples as well, right? Now you know that there is potential, right? And what we look into is the untapped potential in the deep water region in specific to India, right? So 10 out of the 26 sedimentary basins are situated in the offshore region, right? And about 3 to 4 of them are tagged as category 1, that's it. But whereas the offshore basin accounts to about 59% of the total resources. And when you're talking in terms of yet to find volumes, these basins account to about 6.5 billion barrel of oil equivalent, right? And out of that, about 78% is towards the deep water. Now these numbers are in-house estimated and are risk based on our internal estimations that are there. And when you look at the chart on top, you can see the likes of Andaman Nicobar, Kaveri, KG Basin, Kerala Konkan with huge potential as well. And when talking in terms of acreage offshore, acreage of the offshore basins, these basins account to 51% of the total basin area, right? So you have large acreages in Kerala Konkan, in Andaman, in Kaveri, in KG Basin, etc. as well, right? And when talking about the average exploration well density, which is nothing but the number of exploration wells drilled per 1,000 square kilometers of the basin, you see that for most of the basin, it is well 0 or below 0, except for Mumbai offshore or KG Basin, where there has been some amount of drilling that's been happening, right? So again, this gives you an understanding there is potential and there is need of more exploration that is being required. Now, let's understand how deep water in general is competitive or compared with other supply segments, right? For this case, what we have done is we have benchmarked different supply segments. For example, onshore opaque, offshore shelf, tight oil, offshore deep water, onshore non-opaque, and oil sands. And this is done on the global level where the assets selected are of the discovery life cycle, right? And you compare these supply segments with different dimensions, such as the undeveloped liquid resources, your average Brent break-even prices, your average payback time at $80 per barrel, which is nothing but the time between your sanctioning and the time when the project repays back its costs. and your average IRR at $80 per barrel again, which is nothing but the internal rate of return, and it's basically the maximum discount rate at which your NPV gets positive, and you have your average CO2 intensity kilogram per BOE, right? And when you compare all these supply segments, then you see that offshore deep water is quite competitive compared to other supply segments as well. You look at the average Brent price, it's at $46 per barrel. The payback time is less, which is 7 years. Your average IRR is on a high 31%, and even your CO2 intensity emission is just at 10 kg per BOE. So which gives you an idea that the deep water side is kind of competitive even on the economic side, and even when you're talking on the emission side as well, right? Now, what we will do now is just have an understanding where we are, India, in terms of deep water exploration, and compare that to some of the global deep water basins, and see what exactly is the difference happening, right? For India, what we have done is we have considered the Krishna Godavari basin, and for some of the top global offshore deep water basins, what we have considered is the US Gulf deep water, the Santos in Brazil, the Lower Congo in Angola, you have the Guyana basin, and the Levantine basin in Israel, right? And when you compare the top 3 basins, that is the US Gulf, Deepwater, Santos, and Lower Congo, these basins have large volumes being discovered. That is about 30.1, 41.3, and 19 billion barrels of oil equivalent being discovered. And this has happened by drilling a lot of exploration wells, right? For example, when you look at the well densities, about 9, 2, and 4.5 in the deep water. On the other hand, there are a few newer basins as well, where the number of exploration wells drilled are on the lower side, but they have managed to discover large volumes in much quicker time as well, right? And when you compare these basins with KG Basin, just considering the deep water, the number of resources being developed is also on the lower side. The wells drilled are also on the lower side, which again gives you a lower well density. So it kind of gives you an optimism that require more exploration drilling, and there is potential that can be found over there. Another example is when the chart that you see is nothing but the creaming curve chart, where the y-axis is the cumulative discovered volumes, and your x-axis is the basin well number, right? And the black line, what you see is the KG basin, which is kind of plateauing. And when you again compare that with the Lower Congo and also US Gulf, that itself were plateauing at the number of wells. But with more number of wells being drilled, you see that the Lower Congo and the US Gulf deep water had been accumulating volumes and was on a vertical trajectory as well. So that kind of gives you an idea that there might be potential where we won't have to drill exploration wells. We need more seismic and studies. Right? Right. Now, just having an understanding on the global perspective, what the global deep water investments are looking, what the trend are looking at. The chart that you see is the global conventional deep water exploration investments, right? The years 2015 to 2014 were quite good for deep water investments. The companies were quite optimistic. They were trying their hand in the deep waters. You had your oil prices at $180 per barrel, and post that there was drop in oil price, and then you see the investment coming down as well, right? So the companies were kind of cautious. And then again in 2019, 2020, you had your COVID, and you also had further restriction, which caused the spending to come down. But however, post 2021, there is a modest level of optimism being built up, where we kind of expect that investment to be coming back to the 2019 levels, right? And these investments that we're seeing are, if you say, largely concentrated in the Atlantic margin side. You have your Western African side, you have your Brazil pre-salt, and you also have your East Mediterranean and some in Asia, right? And when talking about India, there's quite optimism being built up in India as well. For example, we saw the Kaveri well, that is the Chola well, which turned out to be good. We have further exploration in Kaveri. We have the Andaman Nicobar, where ONGC is planning deep water exploration, and we also have the Kerala Konkan, where there is more activity expected. So there is kind of a sense of optimism that is being built up in the deep water, right? And yeah. And when you compare it with how the operator segments are, about more than 50% of the spending, for example, just considering 2025, are coming from the majors and the INOCs and NOCs. So you know that which are the companies that are doing this kind of investments and who have the most technology capabilities, etc. Right. Now, similarly, just looking at the total deepwater greenfield capex by the sanctioning year or by their approval year. So even this trend, when you see, kind of followed the earlier trend where there was a drop post 2015, we had a modest pickup, and then again drop in 2020, and then again we're seeing a modest pickup coming up. The interesting part to see is the 2026 levels, and even post that, where we kind of estimate or we assume there will be a lot of greenfield capex investment happening in the deep water, especially in the likes of South America, Africa, Asia, and North America. So, South America, you have again Brazil and Guyana. In Africa, you have Libya, Angola, you have Namibia, and in Asia, you have again Malaysia and Indonesia as well, right? And in India, we had seen some reasonable amount of sanctioning happening. That is from 2017 to 2018. This was largely in the KG Basin, in the cluster fields, if I'm not wrong. And we are estimating more sanctioning in 26, 27, but again, more concentrated in the KG Basin itself. Okay. Now just to round it off and to understand where the deep water exploration is heading in India and what the government has done so far. First thing is that they have opened up the no-go areas, which is a crucial step that has been taken. So as you mentioned, about 99% of India's exclusive economic zone is now open for operation. That's a big thing, right? And there are faster approvals for offshore now, right? The clearance for offshore and are directly administrated by the central government, so that results in simple and faster approvals. There's a lot of promotion of MOUs where IOCs are aiming to exchange technical expertise in the deepwater areas. We have seen a lot of MOUs with ExxonMobil, with Total Energies, with ONGC, etc. And recently we also had the oil field amendment bill as well. So the bill was passed this in 2024, which again addressed to the regulatory challenges and also streamline the processes, basically your licensing term, the extension, and also how it's being processed, right? And the last is the upcoming OLAP round, right? So just today, we got an announcement that OLAP round 10 is going to be announced, right? About 25 blocks, out of which 19 are offshore. And if I'm not wrong, there are about 12 are targeting the ultra deep water blocks, and again in the no-go area. So there is a good number of optimism that's being built up by the government, and something to look about in the upcoming future years as well, right? That's from my end. Thank you.
Thank you, Taib, for a wonderful presentation. I may have a quick question. So you're, in principle, it looks like you're saying number of wells are not being drilled enough in order to capture the full potential, and stopping the number of wells at premature stage is not getting you where you want to with the deep water. This is what is a kind of message I see.
Yeah, so it was basically benchmarking the amount of well density that you're drilling. So for example, the KG Basin has certain amount of area and how much coverage is being done, right? Mm-hmm. And when you're just talking about the total deep water offshore area, your Kerala Konkan is not explored, right? Then you have a lot of area in Kaveri that is there in the ultra deep water. So there's a lot of area that is still underexplored. There hasn't been much studies done. So that is what the point is.
So minimum number of wells is not there. That's the point. All right. Thank you. All right, any other comments or questions if you have to the others, please, you can meet and discuss with them right after this. They will be here at this, yeah. So last but not least, we are coming back again to the wellbore, near wellbore. It is by Andrew Heron. He is the engineering manager from Baker Hughes. He's going to talk about a hybrid drill bit technology called Chimera drill bit, significantly reducing the rig time in the lost zones as well. Yeah, Andrew, floor is yours.
Okay. Thank you, Mr. Chairman. Just loaded. Oh. So yes, good afternoon, everyone. I'm Andy Heron, drill bit manager in Kuwait for Baker Hughes, and I want to bring to you a methodology, really, of drilling large diameter holes in lost zones, and how to approach it and save a lot of rig time. So the background to this situation is that you can see here, I've got two graphs drilling to the kickoff point because these are deviated wells. And the completion sizes by year. So you'll see that if you look at the bit size that have been utilized to drill to the kickoff point, these are getting larger. And directional work used to be historically done in 12.25 and 8.5 inch sizes, which meant that the wells were completed in 6 or 6 1/8. But you can also see there from that graph on the right that the completion sizes of these wells has been increasing because the directional work is done earlier on. Now, we are going to talk about 22-inch drill bit size, hole size, but the initial, the well profile demands a vertical run, then followed by a directional run. It's not practical to do all the work with a directional assembly, simply because we have lots of losses early in the section, but the losses are patchy. Sometimes you get total losses, sometimes you get 50% losses, sometimes you get very few losses, so it's very hard to predict how the well is going to behave, and therefore it's not particularly easy to design a one solution fits all BHA to finish the section, drilling from vertical out to maybe 14 or 15 degrees. With big bits, of course, big PDC drill bits generate a lot of torque. Sometimes rigs haven't got the power to manage that torque, and because of the losses and reduced flow rates that are used, it's not practical to utilize a motor with a PDC bit to substitute for let's say, a lack of surface torque capability. TCI bits in these applications are slow comparatively, so your drilling time's extended, which then means that you're exposing the well is open to in these lost zones for longer, and of course hole condition doesn't get any better the longer it's open. So what was the strategy here? The strategy was to find a solution to allow us to drill as fast as possible, to limit the time that the well is uncased. Because of total losses and severe losses, then of course building mud on the fly is necessary. We have to wait on water sometimes. You're losing fluid to the formation, of course, but the strategy here was to drill as fast as possible without consuming all of your drilling fluid. Now, it's only gel mud, but at least it has carrying capacity, it has some lubricity, whereas water simply does not. If you turn the well over to water when you've run out of mud, then your friction goes up, and that potentially generates vibration, which can lead to bit damage. And then basically at the end of the day, we try not to stop drilling until it's excuse me, absolutely necessary. In other words, drill as fast as we can to save time. So historically, as I said, it's not really suitable for PDC drill bits, so these wells have been drilled with tungsten carbide insert bits. And here we have a graph showing two metrics. The dotted lines on the left are the actual on-bottom drilling time taken to finish the section, and the solid lines further to the right are the total time it took to finish the section. And by total time, I mean the time from when we started drilling to when we reached the section TD. We didn't include any time pulling out of the hole for these metrics, but we just wanted to know how fast do these bits really drill and how long does it really take us to finish the section. So you'll notice there the scale on that there is in hours. You're looking at anything from 50 odd hours up to 120 hours to actually drill, but you can be looking at anything from 120 hours to 240 hours to actually finish. So there's a lot of time in there a big difference between the actual drilling time and the actual time taken. So if we break that down, we can see that the TCI bits drill at about an average of 35 feet per hour, and that the total time taken is about 170 hours average. So if you take 83 hours or 84 hours as the average to actually drill, on bottom drill, and 170 hours to finish, then you're looking at a difference of 3.6 days of operational time doing other things, not drilling. So that's a considerable cost, and the reason for that is with TCIs you're drilling slowly, you're losing a lot of fluid, you pump away all your mud, you pump away all your water, you have to wait on water trucks, wait on water wells, you have to pump cement plugs is a common cure for these issues, and then you have to wait on cement, or you have to pump large concentrations of LCM through the PBL subs because the nozzles and the bits, the concentrations are such that you would just clog the bits, so you use PBL subs, and then you have to wait on those pills soaking, and then even when you go back to drilling, you may not have fixed the problem. So these are the kind of things that eats up all that time. So generally speaking, as I mentioned, PDCs aren't particularly suitable for this operation. There's also a risk of vibration and twist off, which has happened numerous times. In fact, when it's been attempted, motor assemblies wouldn't be suitable because they often reduce the flow down to 500 gallons a minute, maybe even 400 gallons a minute. And whenever in other parts of Kuwait where we use these bits, we're flowing at 1,000 gallons a minute. And as I said, TCI bits drill quite slowly. So really neither of those two are a solution for this problem. But hybrid bits being those that contain both PDC elements and roller cone elements, have certain advantages because they have roller cones. They generate less torque than a PDC, more torque than a genuine TCI bit, but less torque than a roller cone, PDC, sorry, which allows. I mean, you don't have to have the world's most powerful rig to use these bits because the torque generation is lower, and it drills much faster than a TCI because it has these PDC elements. Now, I said we use these bits in other fields. We do. This was a new application for this bit because this is shallow drilling. We use these bits in deep drilling. So these bits here are going in about 500 feet in the deeper drilling application where the casing profile is all set much deeper. These bits go in about 5,000 feet and come out about 10,000 feet. So it is a different application, but we thought that the bit had merit for this much shallower application in the south of Kuwait. So this is the bit that we used. It's a Chimera drill bit, 22-inch K5 M633, meaning it's K5 is the Mark 5, you might say. It's the 5th generation of these Chimera drill bits. And the 6 means it's got 19 millimeter PDC cutters and 3 cones, and it looks like it's got 6 blades, but we actually say that it has 3 primary blades. So that's the nomenclature there. So how do we go about doing this job? Well, planning is everything. So load up the pits to maximum. Get as many water trucks in this application because it's a land job, but of course if you're offshore you don't have this problem, but get as many water trucks as you can. Make sure your water wells are working and the pumps are working well. Do what you can to maximize mixing capacity at the hopper. And the key to this, I feel the key to our success here, one of the main keys, is that we always pump mud. We don't stop. We try to drill so fast so that we don't have to stop. Because like I said, even though it's very basic mud, it still has lubricity, and it still has carrying capacity that helps us drill better. Like I said, normally in this application we would maybe start the section at 750, 800 gallons a minute, but then when we have losses we have to reduce the flow. We were concerned about that as a drill bit company because, of course, PDC drill bits can thermally degrade if they don't get cooled enough. So we were concerned that 500 gallons might hurt the bit, but in actual fact it didn't. The PDC cutters were fine, and like I say, we tried not to stop drilling. So what did we do? So this is the same kind of graph as I showed you for the historical TCI performance. This is time, depth against time. So the dotted lines again are on bottom drilling time for the Chimera hybrid drill bit, and the solid lines are the time it took from the start of drilling to get to section TD. And you'll notice the scale on the top there only goes up to 70 hours. The other scale for the TCI bits went way up as far as 240 hours. So you can see that there's comparatively speaking, there's very little time wasted between actual drilling time and the time to finish the section, and that was our goal. We just kept going and tried to minimize all the dead time that comes from pumping plugs and LCM and so forth. So to put some numbers on that, the average time for the bits to be in the hole for the 4 wells that we trialed, it was 32 hours, and the average total time from beginning to TD was about 50 hours. So the difference is really less than a day, 0.7 of a day. If you remember, we were 3 days, 3.6 days, I think, on the previous example where the TCI bits were used. So economically, this is very important. This graph again is a comparison of the on-bottom time between the PDC bits, which are the dashed lines, and the TCI bits. So you can see that the actual drilling time is much less compared to the old historical method of using TCI bits. And again, if we just quantify that, we can see that on average, on bottom time saved by using a Chimera bit is 2.1 days. Excuse me. But that's only the on bottom drilling time. When you quantify that, you can see the left is the best of the TCI bits against the best of the Chimera drill bits, and you can see significant ROP improvement and reduction in cost per foot. Remembering that the TCI bit is the Chimera drill bit is 3 times the price of a TCI, and we still save money. And then if you look at the average of the TCIs and the PDCs on the right, 270% faster in terms of total time, and 39% cost reduction. So in terms of on-bottom time, we reckon on average we can save about $51,000 of drilling time, actual drilling time. But when it comes to total time, on the left, the dotted lines are the PDs, the hybrid drill bits, and on the right are the TCIs. And you can see there's a vast difference in the total time actually taken to complete these sections. Again, in terms of time, on average, we save 5 days by using this drill bit and this philosophy. And of course, as in most things in life, everything comes down to money. So you can see we reduced section cost there by, on average, 54%, and reduced the cost per foot by about 56% on average. But here's the real deal here. The best of the TCI runs have been against the best of the hybrid runs. We saved 82,000, and on average, we're saving the client 128,000 per run, and that's just in time. In summary, overall, if you take the bigger picture, 61% faster drilling, actually drilling, 71% faster completing the section, reducing drilling costs by 36% of actual drilling costs, reducing the cost of the section by 54%, and saving an average of 128,000. And that doesn't include what the client didn't have to spend on cement plugs and LCM and extra mud chemicals and so forth. And those extra materials, the cost of those could be considerable. So, thank you very much.
Thank you, Andrew, for introducing this new hybrid drill bit technology for this. So this kind of hybrid bit is a mix of PDC bit and a rock wool tricon bit combination, something like that?
Yes. I mean, often a PDC bit is the best bit for the job. Often a TCI bit is the best bit for the job, just depending on circumstances. But there are occasions when there is no one single bit kind of solution in terms of those fixed and rolling elements, but the hybrid bit has both, which means particularly in Kuwait, where there are many formation changes, the Khmer hybrid drill bit is very good at handling transition zones because it doesn't torque up the way a PDC bit might, but it drills much faster than a pure TCI bit.
All right. And this is good for horizontal drilling as well?
It has been used in the smaller hole sizes. This is a 22-inch bit, so we don't drill horizontally with this. But yes, in horizontal work, it has been used. Not particularly in Kuwait. We've had 1 or 2 runs, I think, but certainly across the world, yes.
All right.
So because of the reduced torque, it also makes tool face control very easy.
Yeah. Thank you for a good presentation, and thank you. Yeah, there is a couple of questions. Maybe we can give them an opportunity. Can someone give the mic to the gentleman, please? Yeah, please collect the mic there.
Nice presentation. I am Prashant Murgari from ONGC. I have 2 questions. Number one, what is the loss rate which are used this hybrid bit? Number one, what is the loss rate? It is a total loss or a partial loss?
Well, it's not, as I mentioned, it's not consistent. 2 of those TCI jobs had total losses, and 1 had partial losses of 70%, 70% return, so partial losses of 30. 2 of the PDC, the hybrid runs, had total losses. 1 had 60% losses, so returns only of 40%, and 1 of the wells actually had, on average, returns of 90%. So it's not consistent at all, but it makes it difficult to plan in that way. I mean, if you knew you weren't going to have losses, then you could put a motor in there and maybe use a PDC, but you don't know that. That's the problem. And a PDC on rotary is not the best solution. They have tried it, but it's not the best solution. And the TCI is just slow. So that means they end up spending a lot of time waiting on water, mixing mud, all that sort of thing. So our solution is it's a fast bit in this application, and that's the key. We just drill as fast as we can and try to complete the section without switching the well to water, because when you do, like I say, friction goes up, torque goes up, you risk twist off, you risk bit damage, all that sort of thing.
Thank you. Any cementation issue during casing lowering? Cementation problem, how you address?
Any problem with the cementation after this?
Oh, well, no. It seems to be fine because the losses are at the top of the section. The Damam and the Reduma formations. So that means that you're basically always trying to fill the well up to the top, but it never quite works. So the cementation lower in the section around the bottom of the casing where you need it is not an issue, because the loss zones are so far above you.
In total loss condition,
in total loss condition, how the cementation was done?
Say again?
In the context of the total mud losses, how the cementation was performed?
As far well, I'm drill bits. When we get to TD, my job's kind of done. But
Okay, thank you.
That's fine.
Yeah, I think since the mud losses are at the upper part of the section,
Yes.
so the cementation for the bottom from the casing shoe TD to somewhere in the middle was concluded, I think. Yeah.
Yeah.
Okay, so that's a very interesting discussion, and thank you with considering the time. So we appreciate all your presentations, all the others, and let's give a big hand of applause for all of them. Yeah. So with this concludes this session. Yeah. The next session will start at 10 minutes. Before you depart, please give a pose for the photograph. Yeah.